Hi guys, today we're going to take a look at page 7 of the Unit 7 classwork packet. In Unit 5, we learned that there were 5 ways to prove triangles congruent, right? SSS, SAS, ASA, AAS, and HL. By contrast, there are only 3 ways that we can prove two triangles similar, and those are AA, SAS, and SAS. Let's see how those work, okay? Angle is probably the easiest of the 3 because it's exactly what it says. If I can show that there are 2 angles inside a triangle that are the same as 2 angles inside the other one, that means the 2 triangles are similar, which is a fancy way of saying one is just a bigger version of the other, okay? So let's take a look at this with example number 1. Example 1 on the surface does not look similar, like the 2 angles that they give me are not the same. However, do you guys remember a way to find angles within a triangle? How many degrees are there in total? Well, there are, in a triangle, 180 degrees, right? So if I wanted to, what I could do in order to find the third angle is I could actually go ahead, add them up, subtract from 180. So these two added up together give me 149. And so then 180 minus 149 gives me 31. Let's take a look at the other triangle, shall we? 75, 31, do the same thing, guys, where you add them up. So you get 106, subtract from 180, and I get 74. Do you guys see at least 2 angles in those triangles that are the same as 2 angles in the other? Yes, so we're good. Example 2, it's a little bit tricky because there's actually a hidden pair of angles that are the same. Does anybody see a hidden pair of angles in example 2? I do. I see vertical angles. So those angles in the middle, right, that are formed by 2 intersecting lines are congruent. Therefore, I can say that I have at least 2 angles in each of the triangles that are the same. Thus, the 2 triangles are similar. Okay? Now, SSS, I can't read. SSS is the second one we're going to take a look at, okay? SSS is a fancy way of saying that all 3 sides of one are proportional to all 3 sides of the other. What do I mean by that? Let's take a look at example number 3. Okay? All right, so example 3. Okay? Looks something like this. So they give me 3, 4, 5, and 6, 8, 10. Got it. All right. So in order to check to see if these 2 triangles are in fact similar, I'm going to have to set up proportions and check to see that they are all the same. Okay, so what's the smallest number here? The smallest number here is 3. What's the smallest number there? The smallest number is 6. So I'm going to do smallest over smallest. So far, so good. What's the next smallest number? 4. What's the next smallest number over here? 8. Last but not least, what's the largest number? 5. What's the largest number over there? 10. So, in order for the 2 triangles to be similar by SSS, all 3 of these ratios, proportions, fractions, whatever you want to call them, have to be the same. Let's check. This reduces down to 1/2. This also reduces down to 1/2. This also reduces down to 1/2. Is 1/2 equal to 1/2 equal to 1/2? Yes, in fact it is. So we would say that these 2 triangles right here are similar. Okay? Now, in a case where for some reason you didn't get 3 of the same, what that would mean is that they are not similar, right? In order for this to actually work, you have to have exactly the same ratio for each one. If they don't reduce down to the same fractions, oops, sorry, not similar by SSS. All right? Last but not least, let's take a look at an example of what SAS means. Now, what I want you to notice with the statement SAS, where is the A? What is it in between? It's in between the 2 S's. And so in a diagram, what we're looking for is an angle with sides on either side of it. And what we're checking is to see, I wonder, are those two sides on either side of the same angle proportional? All right. So in order to see how this works, let's take a look together at let's take a look together at example number 6. All right. The reason we're taking a look at example 6 is they're trying to trick you, right? They give you a diagram that's actually not all that helpful. Yeah, which is just kind of rude. So this is 12. That is 21. That's 25. Okay, now here's what I'm going to recommend, guys. I'm going to recommend that you add a few things to this diagram. First of all, do you guys notice that before I even get there, do you guys notice that there are actually two triangles here? There's the big triangle in green, and then there's this itty bitty triangle in blue. Okay, so that's the first thing. Second of all, do you notice that those two triangles happen to share an angle in common? They share that angle right there, the apex angle. All right. Now, I have that angle in common, and notice, for the blue triangle, I have two sides on either side, and for the green triangle, I have two sides. So what we want to do is we want to set up the proportions, just like we did for SSS, and we want to check to make sure they're the same. Let's do that. What's the smallest number in this triangle? That would be 12, right? So I'm going to take 12, and I'm going to put it over 21, which is the smallest number in the big one. All right, what's the largest number in that triangle? That would be 15, right? What's the largest number in the other one? 25. So our job, guys, is to check and see if these happen to be the same ratio. Let's simplify these fractions and figure it out, okay? So 12 and 21, those have a GCF of 3, so this would reduce down to 4 over 7. Over here, there's a GCF of 5, which reduces down to 3 over 5. Uh-oh. Are those the same fractions? No, they're not. So in this particular case, these would not be similar by SAS. In fact, they wouldn't be similar at all because their sides are not proportional, okay? Now, in a future video, we'll take a look at a few more examples of each one because I know that was a little bit fast, but just a few tips and tricks. Tip number 1, be on the lookout for vertical angles. Okay, you want to make sure if you have vertical angles in a diagram, you're going to want to mark them because they're going to be really useful. Tip number 2, be on the lookout for things like this, where either a side is shared or where you have an angle that's shared. In this, with the similarity, it's much more angles that are shared than sides because that's going to end up being a signal that in a proof problem, you may have to use the reflexive property of congruence.